Hello, welcome to Chapter 7, Proof in Quadrilaterals. Section or Lesson 7.1.1, Question 6. Examine the triangle ABC and triangle DEF at the right. Assuming the triangles are not drawn to scale, complete a flowchart to justify the relationship between the two triangles. So let's take a look at the two triangles, see what information we have. We have triangle ABC where angle B is 25 degrees, angle C is 39. So what we'll notice is angle C and angle D are congruent to each other. If we find angle A, we're going to take 180 and subtract the two other angles using the triangle angle sum theorem, and that will come up with an angle of 116 degrees. We could do the same thing with angle F. Take a 180 minus 116 and 39 degrees, and that will give you 25 degrees. So what we find out is we see that all the angles of both of the triangles have corresponding angles that are congruent. Now that doesn't prove congruency, but what it does prove is similarity at least. Let's go ahead and also take a look at the side length. We notice that length AB, which is in between angle 116 and 25, and so that length AB would be the corresponding side for the other triangle between 116 and 25 degrees is 14. So both AB and EF are of the same length. And so now we have an angle, an included side, and another angle that have the same measures. So therefore the triangles are now not just similar, they are congruent. So let's go ahead and finish part A, just kind of talk through that. But let's go ahead and complete the flow chart now. So I went ahead and completed the flow chart, and I need to make sure that each of these bubbles above make the conclusion that triangle ABC is congruent to D or EFD. And I did that one by angle side angle congruency. You could have also done angle side congruency, so that's another possibility. I would have to change my flow chart a little bit to make sure I picked a side that was not included, but that could have been something you also chose to do with that. So just to make sure that that's not the only way that we could have done the flow chart. All right, on part B now, it asks find AC and DF. So BC, since now we know they are congruent, BC is going to match up with, let me fix that, sorry. BC matches up with side length between 39 and 25, which would be DF. So we know DF is equal to CB, and since CB is 20, we know DF is also equal to 20 units. Now to find AC, AC matches up with, so that's between 116 and 39, DE or ED, but we don't know either one of those lengths, so we're actually going to have to use some trigonometry, not right triangle trig, because neither one of these are right angles. We're going to have to use our law of sines or cosines. So let's go ahead and use law of sines. Remember that we can take the sine of an angle, so like sine of A would be over side A, sine of angle B would be over side B, and then sine of angle C would be over the side opposite that, which would be C. So we just have to pick the ones that we need, or the ones that we know, and the one that we need. So I'll just look at the smaller triangle here with the, well, I say smaller, but they're congruent. It looks smaller, the one on the left. And I need to find AC, so I want to make sure that I use the angle for that, which would be angle B. So I'm going to be looking for the side opposite that. So sine of 25 over B. Now I also want to use a side that I know. Now I do know both of those, so it doesn't matter which one I pick in this case, so I'm just going to use A. So it would be sine of 116 degrees over that side opposite, which would be 20. And then now we can do our cross multiplying and solve for side little b, which would be AC, which is what it's asking for in this question. And so I did my cross multiplying, or you can multiply by 20b, however you want to do it, but you get b sine of 116. This is what you get right here. is equal to 20 sine of 25. I then have to divide by sine of 116 degrees. So this right here is what I plugged in my calculator to get the most accurate answer. And I got B to be approximately 9.4, which is side length AC. So AC is approximately equal to 9.4 units. So we have AC, we found DF, and we've done our flow chart. Question 7. Use the relationships in the diagram below to find the values of each variable. Name which geometric relationship you used. The relationships that we use really is going to depend on how you go about doing this, so I'll explain mine, but that's, once again, not the only way. So one of the first things I recognize is that we have parallel lines, which will be important because we can talk about the type of angles, whether it's alternate interior, corresponding, same side interior, things like that, so we can use that to help us out. We also have triangle angle sum theorem. We have vertical angles, a lot of things that we can look at here. So let's just start here, and then we'll kind of go and see what we can find. So the first thing is, here is a transversal that cuts the two parallel lines. So just kind of start filling in some things and see what we come up with. So 63 degrees I could fill in, even though this is not one of my variables, it is the corresponding angle. So since they are parallel lines cut by transversal, the corresponding angles are congruent. So I use 63 there. But then now I can use the straight angle theorem, or the straight angle, to say that, well, D has to be 180 minus the 63, because those two angles have to add up to 180. So I know D, I'm just going to start writing these down as I find them. I know D is equal to 117 degrees, and that was partly from corresponding, but the way I actually figured it out once I used the corresponding was knowing that a straight angle is equal to 180. So we now know this is 117 degrees. We can then use the straight angle again. Actually, we can use vertical angles. Since these two lines intersect, we know that this angle is 63 degrees. And we can now find angle B by using the triangle angle sum theorem and taking 180 minus 63 minus 52. And so came up with B to be 65 degrees. All right, let's look at this angle A. This would be a vertical angle to this, but since we're looking for A, if this is 63, then this whole thing has to be 63. So to figure out what A is, we can take 63 minus 37. And we got 26 degrees for angle A, and that would be vertical angles as to how we figured that out. And then to find C, probably got a couple options on that one. It does deal with the parallel lines as well, and so let's maybe use that. Or we could use the triangle angle sum theorem, because this would be 117 by vertical angles. But let's use the transversal here. So we have the two parallel lines. Here's the transversal. So that means these alternate interior angles have to be congruent, and since we found A to be 26 degrees, then we also know C would have to be 26 degrees, once again by alternate interior angles. And once again, that's only true because the lines are parallel. If they weren't parallel, then those any of those interior angle, alternate interior angle, same side interior angle, corresponding angles, that would not apply if the lines were not parallel. So it's important to know that is true because they are parallel. So I think we answered all the variables A, B, C, and D, and just wrote a couple different ways as to how to find those. Question A. A rectangle has one side of length 11 millimeters and a diagonal of 61 millimeters. Draw a diagram of this rectangle and find its width and area. So we have a rectangle, so draw that out. We have a diagonal of 61 millimeters, and we also have a length of 11 millimeters. And you can notice that this is a rectangle, so we are going to have a right triangle here. And we have two of the three sides, so we can use Pythagorean theorem to figure out the width. We have 11 squared plus, we'll just call this A. A squared is equal to 61 squared. So we have 121 plus A squared is equal to 61 squared, which is 3,721. subtract 121 from both sides, and we will get 3,600, and then we can take the square root, and since we're only looking for a distance, we would only do the positive, but this would actually be the absolute value is equal to 60, so we would get two answers technically when we're solving it. A would be equal to negative 60, and A would be equal to 60, but this one's not going to make any sense for what we're doing because the length has to be positive. So we now know that the width of this rectangle will be 60 millimeters. And remember, your hypotenuse is going to be the longest side, which is 61. So it is a little less than that. So at least it makes sense that the width, as long as it's less than that, it's kind of a quick way that we can check. Then the other thing we need to know is the area, and we can find the area by taking length times width. So now we have the length times the width of 60, and that will give us an area of 660. Remember, it's units squared, so millimeters squared. So now we can add the area, and once again, that's 660 millimeters squared. Question 9, Troy is thinking of a shape. He says it has 4 sides and that no sides have equal length. He also says that no sides are parallel. What is the best name for this shape? So just kind of think about what he just said. He has 4 sides, so we're looking at, potentially a rectangle, a square, some type of quadrilateral, a parallelogram, trapezoid, lots of different options there. So 4 sides, let's go from there. No sides have equal length. Well, that's going to knock out the square and the rectangle. That also will get rid of the parallelogram. And it appears the trapezoid is still in because it doesn't have to have equal sides. You could have one like this, So that's still a trapezoid, but no equal sides. So then the next part, he also says that no sides are parallel. Well, now with a trapezoid, you are going to have a set of parallel sides. So now that one's out as well. So is there any other shape that you can think of that has 4 sides, but no parallel or none equal? Not that I'm aware of. You also, I guess, have potential for the kite. You could have thought maybe that one. Not the best drawing there, but remember that a kite will have equal sides. So no parallel sides, but you have the equal sides. So that's not going to work as well. So it seems like the best answer that we can have for this one is it's really the most basic 4-sided figure that we can have where we don't have anything special, and that's just going to be a quadrilateral. So a quadrilateral is really any 4-sided figure. It's just the ones that we know there's more features to them in terms of equal length and parallel. Question 10. Without using your calculator, find the exact values of x and y in each diagram below. Now, depending on how this was taught in the class and things like that, there are shortcuts to these. If you don't remember the shortcuts, some teachers don't mind. If you just go back and use your right triangle trig to figure these out and approximate them. The question is specifically asking without a calculator, so that's the way I'm going to answer it. But once again, make sure you talk to your teacher and find out specifically if it is okay if you don't remember the shortcut. So this is on example A, it's a 30, 60, 90 triangle. So 9 represents the short leg of the triangle because it's across from the 30 degrees. So what we know about that is we know that the hypotenuse is twice the short leg. So x is going to be equal to 18. The other thing is the long leg, which is across from the 60 degrees, is the short leg times the square root of 3. So the short leg, or the long leg in this case, would be 9 square roots of 3. So I'm going to rewrite this. X is equal to 18 units, and y is equal to 9 square root of 3 units. On part B, we're dealing with a 45, 45, 90. So the sides of a 45, 45, 90 should be an isosceles. So these two sides will be congruent. So y in this case would be 24. And then the hypotenuse is going to be the square root of 2 times one of the legs since they're the same. It's just 24 times the square root of 2. So once again, x is equal to 24 square roots of 2, and y is equal to 24. Part C, we're back to a 30, 60, 90 triangle. Now on this one, we're actually given the long leg of the triangle. So remember on the first one how we talked about you take the short leg times the square root of 3 to get the long leg? Well, what if you want to find the short leg, which is across from the 30 degrees, if you have the long leg? Well, if you multiplied by the square root of 3 to get the long leg, what do you think you do when you're working the other way? Well, if you're multiplying by the square root of 3 to undo that, you would divide. So this would be 8 divided by the square root of 3. And then from there, your hypotenuse is twice that. So if you multiply that by 2, that would give you 16 over the square root of 3. Once again, really teacher preference on this as to whether they want you to simplify the radical or not. So if you do know how to do that, you could simplify it. Otherwise, your teacher would probably allow you to leave it in this form, which would be 8 divided by the square root of 3. And then y would be equal to 16 divided by the square root of 3. Now, if your teacher wants you to simplify that, I will show you that as well. If not, just leave it like that. But what we can do to simplify these is we can multiply by a form of 1, and that would be multiplied by the square root of 3. And the reason that works is because the square root of 3 times the square root of 3 is the square root of 9, which is 3. So this would be the simplified version of that if your teacher asked you to what's called rationalize in the denominator. We could do the same thing on y multiplied by the square root of 3, so we get 16 square roots of 3 over 3. And so that, once again, would be the simplified form where you are rationalizing the denominator. But just check with your teacher if you're not sure. Question 11, solve each system of equations below. If possible. If it is not possible, explain what the lack of the algebraic solution tells you about the graphs of the equation. Write your solution in the form of an ordered pair. Show all your work. On part A, I'm going to use the equal value methods because I have y is equal to and y is equal to both of them. So therefore, I can just set my second half of the equation, negative 2x minus 1, equal to 1/2 minus 16. And I noticed that it says 1/2 minus 16 up here. I do believe that should be an x right there. And based on the solution that they have in the book, it should be. So that should be 1/2 x minus 16. Let's go ahead and get the variables on the same side and the constant on the other. I'm going to subtract 1/2 x to both sides. That's negative 2.5x minus 1 equals negative 16. I'm going to therefore add 1 to both sides. That's negative 2.5x is equal to negative 15, and then divide by negative 2.5, and therefore x would be equal to a positive 6. And then we can plug that back into one of the two equations. I'll go ahead and plug it into the top. Y is equal to negative 2 times 6 minus 1. That's negative 12 minus 1, and that would be negative 13. So it looks like we do have a solution. We're going to write it as an ordered pair, 6 comma negative 13. So that's the point where the two lines intersect. That's what they share in common. That's the solution. On part B, we are dealing with what appears to be some quadratics here, but it is still the equal value method. So let's go ahead and set it up that way and see what happens. We have x squared plus 1 is equal to negative x squared. If we go and start to isolate, so if we add x squared to both sides, it doesn't eliminate the x squared. It does create a 2x squared plus 1 is equal to 0. A couple different ways you could approach this. You could try to factor it. It's not going to work. Could use the quadratic formula. The other thing is, since there is no x term, it's just an x squared. If you subtract 1, we can try to solve this using inverse operations. Divide by 2. And we get x squared is equal to negative 1/2. So normally in this scenario, we take the square root of both sides. The problem is that the square root of x squared is the absolute value of x. That's fine, but the square root of a negative, there's no real solution. So what happens then when we have no real solution? It means that this is going to look something like where you have since it is an x squared, you're going to have a parabola. in this case opening up, and then on this one it's going to be a parabola opening down, and they're not going to intersect. So therefore, because we are taking the square root of a negative number, there is no solution because the graphs will not intersect. The other thing that you could possibly do is use your graphing calculator, or you could just graph them on graph paper, but use it, one way or another, graph each of these and see what they look like and see that they don't intersect.